Hello, everyone. How's Summit treating you so far? Yeah, good. So, quick show of hands. How many of you have ever deployed something to production that immediately broke something important? Thank you for your honesty. It totally happens, right? It's totally not stressful in the slightest. So now imagine doing that in front of millions of people at once. That's what deploying changes on a large-scale supergraph can feel like. Opening night on stage with a packed house waiting. But here's the truth at Zillow. We don't go straight to opening night. Just like any well-prepared cast, we rehearse, we practice, we run through the lines again and again until they feel natural. We trip over stage props, miss our marks, and forget our cues. But we do it in private, behind the curtain, before the audience ever sees the bloopers. By the time the show opens, the performance feels effortless, though it took countless rehearsals to get there. At Zillow, our rehearsal has a name. We call it Shadowrunner. Shadowrunner is a tool that we built to give every change its own safe dress rehearsal before it's exposed to real users. Think of it as a parallel stage, where we can play the same exact script under the same exact lighting, with the same exact orchestra, but without the risk of spotlight. So the key is this. The Shadowrunner doesn't run on synthetic data or simplified scenarios. It works with real production traffic, the same requests and queries that hit our live systems every second. The difference are, these requests are executed in a shadow environment, and where they can be observed, measured, and analyzed without any impact on real production flow. That means we can experiment, we can validate, and we can catch mistakes while they're still harmless. So who am I to be talking about rehearsals? My name is Keisha, and I've been a part of the GraphQL platform team at Zillow for about 3 years now. I first started as an intern on the same team. So since then, I've had the privilege of watching this performance grow from something relatively small into a full-scale performance with dozens of cast members contributing. Over that time, I've seen firsthand how our platform has evolved, how new services, new teams, and new features are layered on top of one another to create something much bigger than any one group can manage on their own. And like any good ensemble, that growth brought challenges. Suddenly, it wasn't about writing code that worked. It was about writing code that worked in harmony with everything else. We had to ask ourselves, how do you keep the show running smoothly when every new team is adding new lines, new props, and new choreography to the script? The more people on stage, the more opportunity for things to collide, overlap, or not land the way we intended. That's exactly why we built Shadowrunner. Think of it as a rehearsal space for the graph. It allows us to take every new change and run it safely, behind the curtain, before it ever steps out onto the main stage of production. With Shadowrunner, we can test, validate, and refine in a controlled environment. So by the time those changes go live, they've already had their dress rehearsal. Today, I want to walk you through 3 things. First, the concept of shadow testing and why it's so powerful. Second, the architectural design of our Shadowrunner tooling and how it works under the hood. And finally, the impact that it's had on our GraphQL platform users in terms of stability and the confidence it gives teams to move quickly without ever breaking the performance. So what is shadow testing and how do we leverage it? Our GraphQL platform is, of course, built around the supergraph, a single unified layer that brings together contributions from dozens of teams across Zillow. Every day, it processes millions of requests, orchestrating them into a seamless experience for all our users. But that comes with complexity. Distributed ownership means distributed risk. Each team is empowered to move quickly, to innovate, to evolve their part of the graph, but that also means the system is only as strong as its most fragile link. It's like a stage performance. It doesn't matter if 99 people hit their cues perfectly. If one actor misses a line or comes in off beat, the audience notices, and the entire production feels disrupted. That's the trade-off of scale. The power of the supergraph is that it lets us move fast and build big. But the challenge is that the cost of the small oversight can be amplified across the entire system. One missing field, one schema mismatch, one unoptimized resolver, and suddenly what feels like a small local mistake ripples outwards, affecting thousands or even millions of requests. To get a sense of Zillow's scale, let's step back and look some of the numbers behind the scenes. Every 30 days alone, our system handles 45 to 55 billion requests. At peak traffic, we're serving 15,000 to 20,000 requests every single second. Our schema is equally vast. Our schema includes 4,000 to 5,000 types and 28,000 to 30,000 distinct fields, each one representing the details and relationships that power the Zillow experience. We manage 200 to 300 entities across the platform, and when you zoom out, that expands to 100 to 120 subgraphs actively in play at any given time. So when we talk about scale, it's not a matter of raw numbers. It's the interconnectedness of all these systems constantly in motion. That's why even a seemingly small use case, a minor data inconsistency, a slight resolver change, and other unexpected behavior can ripple through and become disruptive on a much larger scale. Of course, we do unit tests, integration tests, staging, all those things you'd expect. Those are like rehearsals in a small studio where the cast can focus on the details, break the scenes down into pieces, and work together slowly and carefully. They're essential. They build muscle memory. They give us confidence that each part of the system works in isolation or in a small group. But here's the reality. No matter how good these rehearsals are, you can't fully capture the energy, the complexity, or the unpredictability of opening night when you're still in the rehearsal hall. The timing is different. The lighting is different. The stakes are different. And above all, the audience changes everything. When you put hundreds or thousands of people in the seats, the pressure is real and the performance has to hold up. The same is true in software. Staging cannot replicate production environments. You can spin up mirrors, see databases, and simulate traffic, but it's never quite the same. The scale is smaller, the data is cleaner, the variability is missing. In staging, you don't see the odd edge cases, the unexpected query patterns, the real-life messiness of production traffic. And because of that, something that seems flawless in rehearsal can still stumble when it hits the main stage. That's why tools like Shadowrunner matter. They give us a way to bridge the gap between the safety of rehearsal and the reality of a live performance by letting us test against the true production energy without production risk. So that's where shadow testing comes in, our version of a dress rehearsal on the real stage. Instead of relying only on a small studio practice, we take our changes onto the actual stage under the same lights with the same orchestra, and we see how they perform. The difference is the audience isn't in the theater yet. Here's how it works. We mirror production traffics, the real requests and queries hitting our system every second, and we send them not only to stable, trusted environments, but also to a candidate environment running the new code or schema. You can think of it as a side-by-side comparison, control versus treatment. Both versions receive the same input, and we carefully compare their outputs, latencies, and error patterns. The magic is that this happens all outside the user path. Customers never see the candidate's responses, even if they fail spectacularly. To them, it's as if nothing is happening at all. But to us, behind the curtain, it's a full dress rehearsal. Every cue, every prop, every bit of choreography playing out just as it would on opening night. This gives us the best of both worlds, the authenticity of production traffic with the safety of isolation. We can observe how new changes behave under real-world load, each subtle issue that staging environments never reveal, and build confidence that when the curtain finally rises, everything will hold together. In short, shadow testing is how we turn uncertainty into readiness by rehearsing in the real theater without ever putting the performance at risk. So what inspired us to build the Shadowrunner? When we migrated to Apollo Gateway, from Apollo Gateway to Apollo Router, we had an early lightweight version of the Shadowrunner. We used it to validate the migration by comparing the performance and responses between the two implementations using real representative user traffic. And sure enough, some actors were missing their cues. Because of that early Shadowrunner, we were able to surface edge cases and inconsistencies during rehearsal rather than the live show. What could have been a showstopper in production instead became a quick fix caught behind the scenes, giving us the confidence to move forward smoothly. So with our early Shadowrunner, we first examined performance. In examining the performance difference for this query, we noticed the router returning slower responses. Interestingly, what had been a bimodal performance distribution shifted to a trimodal one on the router. As we dug deeper into the query and the surrounding context, we collaborated with Apollo to identify and resolve some edge cases on the router implementation. They responded quickly, so I'd like to shout out the router team for their partnership in strengthening this router ecosystem for everyone. If we hadn't caught this through shadow testing, those edge cases could have easily led to a degraded customer experience. Instead, the issue was contained early, ensuring that no impact ever reached production. Our response differences also surfaced another issue. In a small percentage of requests for a query, we noticed subtle Boolean inconsistencies in the response. The occurrence rate was low, and so it didn't manifest in error logs or metrics. Left unaddressed, it could have affected downstream business metrics and created hard-to-trace customer experience degradations. Through further investigation, we partnered closely with Apollo to uncover and resolve these mismatches in how queries were being handled. Thanks to their responsiveness, the issue was addressed quickly, and so we greatly appreciate the collaboration here as well. So these two examples show how even in its earliest primitive form, the Shadowrunner proved monumental in ensuring a smooth migration. Catching issues proactively gave us confidence in expanding and investing in a platformized Shadowrunner. So now, full honesty, our first version of the Shadowrunner saved us, but there were so many improvements that could have been made. In those early days of the Shadowrunner, everything was manually done. We devoted a lot of time to manual diff analysis for latencies and responses. We divvied up these responsibilities by team member. So each team member would take 2 to 3 dev days of parsing through response differences as we queried through our query engine. This was multiple weeks of manual effort. Our early Shadowrunner would write control and treatment responses in our object store, and then we would use our query engine to get the outputs. We would track reported differences by hand in a sheet. We would then record the date of observance, the query used to detect behavior, context of the response difference, estimated risk or concern level, our hypothesis for the difference, who reported it, if the hypothesis was validated, and any follow-up stories or action items. In the query engine output, each row was one response for control and treatment. Each person would look through hundreds of rows for an entire day for 2 to 3 days. Then we would go to our spreadsheet and mark our concerns. This didn't include additional efforts for performance differences. Though performance differences were a little bit more automated, we could group by operation names and then do spreadsheet magic, but still, it was very manual and very time-consuming. So during our migration retro, our team thought to ourselves, the shadow testing mechanism was so valuable, but the process took time. How do we keep the best part of shadow testing while making it easier for us? And then we extended this question. If the Shadowrunner helped us, could it not help others? So the answer we arrived to, we platformize it. We got to designing, we got to implementing, and our Shadowrunner was born. So with this then, we had designed and set out to implement a new platformized version of the Shadowrunner. This was tooling that provided analysis on differences in performance and GraphQL responses using sample production traffic in a UI, which we will get to see soon. The Shadowrunner deploys changes in a non-invasive manner, enabling teams to safely collect empirical data in a production environment over time. Small deviations in behavior or latency that are otherwise invisible are surfaced with a Shadowrunner. This would benefit not only our team, but subgraph teams as well. So the Shadowrunner is best suited for validating changes where a service's API contract is consistent, including infrastructure migrations, major version dependency upgrades, changing data stores, shifting frameworks, or even significant refactors. So now that we've covered the concept of shadow testing and how it naturally led us to building the Shadowrunner, let's shift gears and dive into its architecture. Understanding how this system is put together is crucial because each component plays a role in giving developers confidence during migrations. But before we jump into the technical components, let's rewind for a moment and start from the very beginning. Onboarding. How does a user actually get started with the Shadowrunner? To use it effectively, we ask for some information. First, we validate if the use case is a good fit for the tool. This ensures that we're not forcing the Shadowrunner to handle scenarios it wasn't designed to handle. Once we confirm that, we request the basics, a service name and the name of an experiment, which usually ties to their use case. From there, we also collect a few more important details. One important detail we ask for is how many requests should be forwarded into the experiment. This flexibility is key because the Shadowrunner actually isn't limited to production environments. It also runs in development and staging environments too. So this means teams can calibrate traffic levels based on their specific need. For instance, a staging environment might only need a small trickle of requests to validate functionality, while production benefits from larger volumes that mirror real-world behavior. On the other hand, traffic patterns can also vary widely between subgraphs. So a lightly used subgraph might require forwarding as much as 50%, while a larger high-traffic subgraph might handle thousands of requests per second and might only need 1% requests forwarded to generate statistically meaningful results. So now let's talk about the two types of experiments the Shadowrunner supports: subgraph experiments and supergraph experiments. Subgraph experiments focus on a single subgraph. So think of this as testing a back-end change while leaving the subgraph's GraphQL API unchanged. It's a way to validate improvements or refactors in isolation without impacting the larger graph. Supergraph experiments, by contrast, are designed for validating the migration of fields between subgraphs. This is especially valuable when breaking down a monolithic subgraph into smaller, more maintainable ones. The APIs of the individual subgraphs might change, but the supergraph API, the final production that the audience experiences, remains unchanged. So here's how that works for supergraph experiments. We leverage the federation @override directive. In one variant, the old subgraph still resolves the field. So @override is set to 0 in the new subgraph, or it's not there at all. In another variant, we flip that value to 100, handling all traffic for that field over to the new subgraph. Once an experiment is defined, how do we actually forward these requests? We support two flows. In the URL flow, incoming requests are forwarded directly, without modification, to two different URLs. For subgraph experiments, these URLs represent the control and treatment versions of the subgraph. For supergraph experiments, they point to the two different supergraph variations with different @override configurations. In the header flow, instead of new URLs, we modify or append headers to distinguish between control and treatment. This is handy when your subgraph doesn't have a new endpoint, but we can still differentiate traffic using these headers. Another important configuration is allowed operations. While optional, it's especially useful in supergraph experiments. Instead of overwhelming teams with every possible operation, we can filter the analysis down into operations that truly matter for your team. This way, subgraph teams don't get bogged down by the noise of unrelated operations across the broader subgraph. Now, let's move on to one of the most critical safeguards that the Shadowrunner has: allowed attributes. This feature is the cornerstone of how we ensure that data is handled responsibly. Essentially, we require teams to explicitly allow list the GraphQL response fields they want to see in reports. Why? Because this step forces everyone, both our team and the subgraph developers, to pause and ask, is this exposing sensitive or personally identifiable information? Every allow list configuration goes through code review, so nothing slips through without scrutiny. This practice not only protects data, but it also builds a culture of accountability in how teams approach experiments. Let's walk through a concrete example. So imagine this query returning an array of homes. The developers want to ensure that the number of bedrooms for a home is consistently resolved. So they want to examine the response differences for control and treatment for this attribute. They would first need to get it allow listed. To do this, they would request to allow list the attribute homes, bracket star, bedrooms. Notice that because homes is an array, we use bracket notation. So the format we use is actually a subset of JSON path, and we only allow full attribute paths, no trailing wildcards, so we don't accidentally reveal unintended data. If a field isn't allow listed, we don't show the raw values in the UI. Instead, we only display the response difference rates. Once all of this onboarding information is set, the experiment begins. Here's what the Shadowrunner architecture looks like as a whole. The key components here include the Apollo router, the Shadowrunner server, the ETL pipeline, and the front end. Each of these components pulls a service hosting the shared configuration, ensuring the entire system stays in sync. So here's how the workflow kicks off. Incoming requests are mirrored internally. When the router receives a request, it forwards it to the Shadowrunner server. Our server, which is written in Go, supports multiple concurrent subgraph experiments and one single supergraph experiment at one time. Based on the chosen flow, URL, or header, those requests are routed to their respective control and treatment versions. Another critical feature of the server is alias rewriting. So this might sound like a small detail, but it's essential. Aliases are common in GraphQL operations, but they can obscure the real identity of a field. For example, here, someone might alias a sensitive field, which we just call PII field, as something harmless, like city. So without rewriting, this alias could trick the allow list into exposing sensitive data. To prevent this, our server rewrites aliases in the recorded responses, preserving both the original and alias names. Once requests are captured and processed by the server, the next step is persistence. The Shadowrunner leverages a data ingestion and transport pipeline to batch and partition the data, which is then written into encrypted object stores. Partitioning is done by experiment and timestamp, making it easy to isolate data for specific runs and time windows. This careful structuring ensures that our downstream analysis jobs can operate efficiently and reliably. Now let's talk about how that raw data becomes actionable insights. Every morning at 4 a.m. Pacific, 7 a.m. Eastern, our data profiler scans the previous 24 hours of experiment data in our object stores. It catalogs the shape of the data in a data catalog, and then our ETL jobs, written in pipeline, kick in. These jobs perform detailed offline analysis, comparing performance and responses between control and treatment. One important safeguard here, like mentioned before, only attributes explicitly allow listed are recorded in detail. If something hasn't been approved, we simply track the rate of differences that occurred without exposing the raw values. This ensures our reports are both insightful and privacy conscious. Once the ETL completes, the sanitized structured data is written into our NoSQL database. This is our system of record for our reporting. From there, the front-end queries our NoSQL database and surfaces the results through our UI. And of course, reports aren't accessible to just anyone. You have to be authenticated and authorized before viewing our Shadowrunner portal. So that's the architecture at a high level. A lot of moving parts, but each plays a very specific role. The router for request mirroring, the server for experiment rerouting and alias rewriting, the ETL pipeline for analysis, and the front end for visualization. Together, they provide developers with a way to quickly and responsibly understand performance and response differences without combing through queries manually like we had to on a spreadsheet. Instead of manual effort, they log in, open a report, and immediately see results. So let's shift from the back end to the user experience. Here we have some test data and some sample queries for reference. When you first land on the Shadowrunner homepage, you can choose what experiment and time window you want to view. The left-hand panel actually provides search functionality, letting you find specific operations. You'll notice the numbers next to the operations, so that represents how many times those operations occurred. In the overview, we like to highlight the top 10 operations that showed the largest performance differences, as well as the attribute paths with the highest rate of response differences. How we determine that for performance differences is the P90 difference weighed by request count. As for the top 10 attribute path response differences, those are determined by taking the difference count, divided by the request count, and then weighing by request count. So with one glance, you immediately know where to focus your attention. But the real power comes when you click on a specific operation. Here you get side-by-side performance graph comparing treatment and control. Latency metrics like P50, P90, and P99 are displayed clearly. You can also drill down by operation hash if there are multiple variants of your operation. And for convenience, we even provide a direct link to the operation in Studio. At the bottom of the page, you see a breakdown of the response differences for each attribute path. This helps teams quickly spot the difference, which parts are inconsistent between the control and treatment. If you click on a specific attribute, this detailed window pops up. So now here is where our allow list protections kick in. If the allow list wasn't allow listed, everything is redacted. You know a difference has occurred, but you can't see the raw values. On the other hand, if the attribute was allow listed, you'll see the exact values side by side, control versus treatment, along with how many times that exact difference occurred. This is invaluable for debugging subtle inconsistencies like incorrect defaults or missing migration code. And that, in essence, is what a Shadowrunner report looks like. It's a complete feedback loop, from capturing requests to safely securing data to surfacing actionable insights in a UI. Over the course of more than a dozen experiments, this tool has fundamentally changed how our teams manage their GraphQL migrations. So let's talk about impact. Since launch, Shadowrunner has caught issues that traditional testing or monitoring might have missed. For example, subtle performance differences, configuration mismatches, migration oversights, and logical inconsistencies between two systems. These are the type of problems that, left unaddressed and undetected, it could have caused production headaches. And don't just take it from us. One team shared that without the Shadowrunner, they would have not noticed latency issues until they were sending 50% of their live traffic. With the runner, they caught it early. Quote, "The metrics we got from the service before turning up a large volume of traffic wasn't enough to have a good comparison of latencies, let alone latencies per query. Without the runner, I don't think we would have caught that, and we wouldn't have had a clear timestamp of where the latency degradation started." Another team said the greatest benefit was the ability to test a brand new subgraph implementation in a completely controlled manner without worrying about breaking other clients. This was particularly valuable for our project, which handles a high amount of traffic from about 30 different clients, ensuring seamless testing with minimal impact. A third team pointed out that something we've always experienced, staging isn't always reliable. With the Shadowrunner, they were able to validate against realistic production traffic patterns. Quote, "The realistic traffic patterns were the biggest benefit for us, as well as environment consistencies. While we can perform some validation in QA and stage, the services we depend on are not always consistent in their environments, so sometimes it's hard to test all code paths with reliable data in these environments." This team emphasized how much time it saved. Quote, "The Shadowrunner for GraphQL streamlined our subgraph migration by clearly surfacing output differences and providing built-in performance metrics, eliminating the need for custom infrastructure. It saved us tons of time and eliminated unnecessary tickets once we were aware of it." So what they're all saying is, Shadowrunner gave them peace of mind. Teams can safely validate real production requests without any risk of breaking the environment, which dramatically reduces stress during critical migrations. It also brings greater visibility with field-level diffs that clearly explain discrepancies between old and new implementations, removing guesswork and speeding up debugging. On top of that, Shadowrunner enables realistic testing that QA or staging environments simply can't replicate, since dependencies aren't always reliable there. With built-in performance metrics and response analysis, teams get automatic insights without needing to spin up custom tooling. Together, these capabilities have prevented costly production issues, accelerated migration timelines, and built trust across teams. Ultimately, Shadowrunner doesn't just deliver peace of mind, it delivers it at scale. Finally, let's get a look ahead. The Shadowrunner has already delivered enormous value, but we see even greater potential for it. Where do we go next? Firstly, we're always iterating on feedback. We get great feedback from our users, and we note all of this down. Is there a better user experience, more intuitive reports? We're eager to tackle these. We also want to support more protocols, enabling other APIs such as REST or gRPC in addition to GraphQL. We want to deliver faster insights through live-streamed reports, not just daily and not just on a 24-hour basis. And we also want to simplify setup by doing configuration directly from the UI. Ultimately, our vision for the Shadowrunner is to become a rehearsal stage for distributed systems, not just GraphQL, a place where developers can test safely, catch issues early, and build with confidence. Really quickly, I'd like to shout out my team for the great work they did and continue to do to make the Shadowrunner what it is today. So to wrap it all up, shadow testing is our dress rehearsal. It fills the gap between small-scale pre-production tests and the full chaos of opening night. If we have safe rollouts, we have happy users. My challenge to you, if you're running a distributed system, don't go straight to opening night. Build your rehearsal stage. You can't have a place to safely make mistakes if you don't build it first. Non-invasive testing should be a first-class platform offering. Because at the end of the day, the best production bugs are like missed lines in rehearsal. No one in the audience ever knows they existed. Thank you.